Hi again, everybody. So we're gonna have one last video for this type. And this one is gonna be a strategy that's a little bit different than what we've been using so far. And I especially call it, I've named it like that last year. I call it dark magic because this strategy looks a little bit like it's dark magic. It's not actually magic. It's something that is completely natural, but when you first see it, it's kind of it's a little bit different, let's put it like that. So when are we going to use this strategy? If you look at the example that I'd already put down there, so essentially with this example, the thing that is kind of bothering us is the fact that you have a base x here, you have a base 4 here, you have a base 2 here, and you have another base 4 here, and there's no way you're going to be able to transform it so that on the left side you have the same base and on the right side you also have the same base. You could use it maybe doing the exponents things, but it's going to be a little bit complicated. This method actually makes it really nice and simple once you understand how to use it. So without further ado, I will show you what to do. So first thing that you should always do is, surprise, surprise, the domain. Let's do that. So what do we have? We have base 4, we have base 4. So base is unnecessary. And then we have an x and an x for the argument. So same argument. So your domain is simply x bigger than 0. Isn't that lovely? Okay, so now that we're gonna solve. So I wrote here what we're gonna do is we're gonna take the log on each side. It's the same idea as if we were to, for example, square both sides, or take the square root on each side, or whenever you're taking an operation and you're doing it on both sides of the equation, which is something we're allowed to do. That's what we're going to be doing now, but instead of using an operation that we're used to, we're going to be using log. So the first thing that you should look is what logs do you have in your equation. So in this case, you have a log base 4 everywhere. So log base 4 is what we're going to be using. So what I'm going to do is on each side of the equation, I'm going to take the log. Note, I'm not saying I'm multiplying by log because that's not exactly true. Taking the log it's different. It's the same way that if I take the square, it's not like multiplying by 2, it's something different, right? So the language that I use is pretty important here. We're taking the log of each side. So if I do that, what is it going to look like? I'm going to write it in a different color. So we said since we have log base 4 already, this is how we decide what base we use. Then I'm going to write the expression that we already have. And then if I'm taking the log on one side, I'm taking the log on the other side as well. Same rules apply as per usual. All right, this is where we're at. So as you can see, the things I have in black are just your original equations, and then I've added a log in front of it. So now that we have logs on each side, what we could do is use the exponent property. So remember, if you have an exponent on the argument, you can simply bring it to the front of the expression. So we're going to do exactly that. So I'm going to use colors again. So for the exponents, I'm going to draw in green. So this exponent that I'm taking, I'm bringing it to the front. So we're going to have log base 4 of x minus 2. I'm using bracket because the minus 2 is not inside the log, it's outside. So then we have our log of x that's left. Same for the other side. So we're going to take the exponent, bring it down to the front. So we're going to have 3 log base 4x minus 1. Our log base 4. And finally, a2. All right. So as you can see, the nice part about this now is it's no more an exponential equation now. It's just a basic logarithmic equation. So that is super convenient because from this line, you should actually be able to solve that. I'm still going to do it with you, but from there here, this should be pretty obvious. I forgot the 4 on the base here. Okay, so let's see. So I'm going to open my brackets and see what happens. So we get log base 4 of x squared minus 2 times log base 4 of x is equal to, notice this is a number, log base 4 of 2, I think that's just 1/2. So we're going to have 3 over 2 log base 4 of x minus 3 over 2. Now, if you notice, we have the same thing, but one of them is squared. So whenever you have that, by now you should know that this is a call for substitution. I don't know what just happened. So we're going to take t. T is equal to log base 4 of x. So we're going to get t squared. This is going to be a minus 2t minus 3 over 2. So what do we get? Minus 7 over 2. And then finally, for the number, it's just going to be plus 3 over 2. And that's going to equal 0. Let's multiply everything by 2, shall we? This is supposed to be a t plus 3 over 2. Not 3 over 2. I think I'm tired. Just 3. All right. So what from now? We probably want to do the discriminant or factor. Let me see if I can factor this quickly. I get 2t minus 1 and then t minus 3, and that's equal to 0. So we have two potential solutions, 1/2 and 3. Let's solve for that. So we know that this is going to equal to, this is actually going to be a log base 4 of x is equal to 1/2. So x is going to be equal to 4 to the power of 1/2, which is just 2. So that's our first solution. Second solution is going to be log base 4 of x is equal to 3. So x is equal to 4 to the power of 3, which, if I'm not mistaken, is 64. What's our domain? I don't remember. X bigger than 0. So these are both acceptable answers. So x equals to 64, x equals to 2 are your two answers. I hope this makes sense. I'm just going to recap quickly in case you need it. So the essential step that was different compared to the other problems that we've seen was to take the log on each side. This was the big deal here. And like I said, I picked log base 4 because it was already a log base 4 in this equation. So that's how I decided to pick a log base 4. So now once I took the log on each side, I was able to use the properties of log, which got us out of this unfortunate situation of having this awful equation. We managed to make it in a much nicer one. I hope this video was helpful. Let me know if you have any other questions. Have a good one. Bye.